Hello, this is Mrs. Wong. We'll now do a run-through for your 2E revision worksheet for Term 3 WA for Set 2 on Chapter 8, Congruence and Similarity. For the first question, we are given the two quadrilaterals being congruent to each other. One of the first things we can do is to draw the two quadrilaterals in the same orientation. The reason why we do so is that we can easily compare any corresponding lengths or corresponding angles easily, and reduces the chance of careless mistakes here. So the length of XW is the same as the length of BA, which is 12. The value of Y, is actually this angle here. And I know that the sum of angle in the quadrilateral will have to add up to 360. So that will give me the value of Y. The value of X, so this is 2X, which is equals to 150, because they are corresponding angles, they should be the same. And that will give me the value of X. For question 2, similarly, we also have two triangles that are congruent. So what we can do is to draw the two triangles in the same orientation. Okay, so what I did here was I let PQR stay and I drew PSR out and then put in the information that I have. Okay, so these two angles are the same, so they are 30 each. That's what we have here. That will help me find angle PRS. PRS is this angle here. So I use sum of angle in a triangle to help me find angle PRS. Then I need to find the parameter of this quadrilateral. The parameter of this quadrilateral includes PS, PQ, RS, and RQ. Okay, and then PS and PQ are the same length, 8 cm. RS, RQ are both the same length, 6 cm. So the parameter is 28 cm. For question 3, we are now looking at two similar quadrilaterals. So what I've done here is to draw the smaller quadrilateral in the same orientation so that I can easily compare corresponding lengths and angles. Now when they are similar, the angles will actually be the same. So I do know this is 74 degrees, I do know this is 18 degrees. Okay, the lengths are actually fixed. The ratios of the lengths are actually fixed. Okay, so I can easily compare them as well. So they want us to determine the angle of GDE. So angle of GDE is the same angle as ZWX, which is 18. Part B wants us to find the length of DG. So DG over here corresponds to WZ. So DG over WZ. Okay, so they correspond to each other. It would be the same ratio as, so I need to find another pair of corresponding lengths. So I do know DE and WX. So the ratio of DG over WZ should be the same as the ratio of DE over WX. So with this, I put in my values, cross multiply to get DG is 4. Question 4. Parallelogram PQRS is an enlargement of this parallelogram. So the first part wants us to find the scale factor of enlargement. So the original parallelogram has been enlarged to form the new figure. So my scale factor would be the new over the original. I will use the lengths to help me figure out the scale factor. So a pair of corresponding lengths that we have is NM and SR. So it's 13.8 over 6. So the scale factor is 2.3. So when I have the original parallelogram, scale factor of 2.3 means the lengths will be multiplied by 2.3. The angles will be kept the same though, to give me my enlarged image here. For PS, okay, so now since I have the scale factor, it's quite simple actually. I can just take 8, multiply by 2.3. Okay, so I can actually take 8, multiply by 2.3 to give me 18.4 cm. Of course, you can also do this. Okay, so if you are not so sure of your answer in part A, what you can do is to stick to the ratio. So PS over corresponding KN will be equals to RS over MN. So that would still give you the same answer. Okay, part C, the area of this parallelogram is your base times your perpendicular height. Okay, so your base length times perpendicular height. So my base length, if it's 6, okay, they tell us that the perpendicular height is 4.8. So that will give me the area of the parallelogram. Question 5. Given the scale of a map is 1:50,000, they want us to write the scale in this form, where they want the units to be 1 cm is to h kilometers. So I have to change cm to kilometers by dividing by 100,000. So 1 cm is 0.5 kilometers here. So my h is 0.5. Part B will be quite a simple calculation. Since I know 1 cm is to 0.5 kilometers from part A, 8 cm on the map will be represented by 4 kilometers. This is because I multiply by 8 on both sides. For question 6, given the scale, they want us to do something similar to question 5. So I do the same, divide by 100,000. I get n is 0.25. Part B tells us that the distance between two towns on the map is 30 cm. So in this case, if I multiply 30 to one side, I need to do the same on the other side. So I will get 7.5 kilometers being the actual distance between the two towns. Now for part C, it gives us the actual area of a lake in kilometers square. They want us to find the area in centimeters square of the lake on the map. So we have to do a bit of conversion. Okay, so we do know the length conversion, 1 cm is to 0.25 kilometers. If I want to find the area conversion, I will actually have to square both sides. Okay, so I need to square. So 1 cm times 1 cm gives me 1 cm square. 0.25 kilometers times 0.25 kilometers will give me 0.0625 kilometers square. Okay, so I have the area conversion. They give us the actual area as 2.5. So now I'm trying to change the value on the right hand side of the ratio to 2.5. Okay, so I can easily do that by changing it to 1 first. So any number to change to 1, I just have to divide by the same number. So I will do the same on the other side. So you see that I have 1 divided by 0.0625. Then I multiply by 2.5 on both sides. So you see that I have 2.5 over 0.0625. So I key this into my calculator to get 40 cm square. This to 2.5 kilometers square. So the area of the lake is represented by 40 cm square on the map. for question number 7, they give us the area being 4 cm square on the map, representing an actual area of 2.25 kilometers square. So they give us the area conversion. And part A wants to find the area on the map, which represents an actual area of 27 kilometers square. So what we will do is, I want to get 27 on my right hand side. So if you are not able to do it right away, you can change to 1 kilometer square first on the right hand side before changing to 27. So here I need to divide by 2.25 and I multiply by 27. So I do the same on the other side. Divide by 2.25 and then multiply by 27. Key in the value and I get 48 cm square. So the area on the map is 48 cm square. Now part B requires us to change the area conversion to that of length conversion. So, So for this part here, what I'll do is to first simplify. Okay, so I have 4 cm square. I want to change it to 1 cm square. Then when I take square root on both sides to convert the area to length, okay, so square root of 1 is 1. So this keeps things less messy. Square root of this 9 over 16 gives me 3 over 4. Then they want the distance on the map to be 7.5 cm. So I multiply by 7.5 on both sides to give me 5.625 kilometers. So the actual distance is this. I do not need to round this off because this is an exact value. Now part C wants us to now write down the scale of the map in the form of 1:n. So 1 cm is 3 over 4 kilometers. You can also write this as 0.75 kilometers. Then I need to convert it to cm. Okay, so because if I want 1:n, the 2 needs to be of the same units. So I multiply by 100,000 to get kilometers to cm, and that will give me 1:75,000. So the scale of the map is given as this.